Okay, the next problem is problem 5 for 6.3. It gives us a circle. It says it's centered at 2, 2 and has a radius of 8. So I drew it here in the plane. And then it says that this point 10, 2 over here should correspond with t equals 0. So what that means is if we start making a table again for t, x, and y, when t is 0, our x value should be 10, and our y value should be 2. So we need a vector equation for this. So there's our vector in terms of t. So the x coordinate of that vector has to start off at 2 plus, and then we want to basically add and subtract here to go back and forth from 10 to negative 6 here. So actually what we need is 8 cosine of t. Now that might be confusing at first, but if you think about it, cosine starts off when t is 0. The cosine of 0 gives you 1, so that will give you the 8 and bring you to this point right here, which is exactly where we want to be. Because we'll get, if this is 1, we'll get 10, which is exactly what we want for x. And while that's happening, then obviously then as t increases, cosine fluctuates back and forth between 1 and negative 1, so eventually this is going to be negative 1, in which case we'll go all the way back to here. So, the cosine makes this thing reciprocate back and forth here, which is exactly what we want. Now while that's happening, we need the y-coordinate to start off at 2 as well, and then be 8 sine of t. And the reason it's 8 sine of t is because of the same thing. We need it to start off at 2 here, so we need this to start off at 0. And when you plug in t equals 0, the sine of 0 is 0 on the unit circle. So that thing starts off at 2 and then fluctuates back and forth between then what would be positive 10 and negative 6. I know it's really tricky, but it's a good application problem as far as how to write a vector parametric function. Then we probably won't do that on the test, but really good practice for calculus. Okay, the next problem is very similar. Only this time we're not going to give it as a vector equation. We're going to give it as parametric equations in terms of x and y. So these are like the x and y components, and they both vary in terms of t. So when you graph the circle, x of t, you can see starts off at negative 5. And then we need to add to that the radius here and fluctuate back and forth from 0 to negative 10. So what we need is, once again, the same thing we did last time. We need the radius, which is 5, times the cosine of t, because cosine starts off at its highest value of 1, so we'll start off at 0 here. And then as we rotate around over here, we'll get to eventually, when cosine's at its lowest value, negative 1, we'll get to negative 10 back here. We'll just do the same thing for y of t then. Start off at negative 1 for the y value and do 5 sine of t. And, make sure that this checks out so that when you plug in 0 for t, this thing goes to 0 and you start off at negative 1. And then, the sign fluctuates between negative 1 and 1, so you're going to end up adding and subtracting 5 from negative 1, which is exactly what we want for our y values or our range. So here's our parametric equations, x in terms of t and y in terms of t. Now if we wanted to write this as a vector in terms of t, like we did the last problem, we would just put the x coordinate in first, cosine of t, and then we'd put the y coordinate in second, like this. Okay, the next problem, 7, wants us to go back to from parametric equations into function notation. And that's actually pretty easy to do because we have x varying in terms of t and we have y varying in terms of t. So what we can do is we can solve one of them for t and substitute it in to the other one to get rid of the parameter t. So we have x equals natural log of 5t, and I'm going to solve this one for t. So I'm going to subtract 1 from both sides and then multiply through by a negative 1. So I get t equals negative y plus 1. And then I'm going to substitute that in right here for this t. So I get natural log of 5 times negative y plus 1. And now I need to solve for y. So I'm going to do change this into exponential form. You can take both sides to base e, or you can do base to the exponent equals the argument like we did for logs. So we do e to the x equals 5 times negative y plus 1. I divide both sides by 5. That leaves me with e to the x equals 1 minus y. I'll write this as 1 minus y, I guess. You can switch these two. Subtract 1 from both sides. Whoops. This should be divided by 5. Now I can subtract 1 from both sides, and I have e to the x over 5 minus 1 equals negative y. Now multiply through by a negative sign, and you'll end up with this right here, which is your answer. You can enter it in like this if you want. That's fine. Or you can rearrange it, but that's your answer. That's y in terms of x. Okay, the next problem we want to do the same thing. Solve one of these for t and plug it in. So I'm going to take the first equation here, and I'm going to do natural log base e of x. The argument equals the exponent because the log is an exponent, so I changed it from exponential form into log form. And then I can divide by negative 4, and that gives me t. Now I'm going to substitute that t back in right here. So I'm going to end up with y equals 3 e to the 5 times t, which is this natural log of x over negative 4. And that's my answer. I mean, you could simplify it a little bit maybe by writing it as negative 5/4 natural log of x if you want, but that's not too much simplified. That's your answer. Okay, the next problem gives us a curve, which is a line here. This one, if you put it in standard form, starts off at negative 1 here and has a slope of down 1 over 1. So we know we go down 1 over 1 and so on. That's this line right here. I want to know which of the following would be a parametric equation in terms of x and y. So this is kind of like a vector where it's giving you the x, y ordered pair, x being here, y is being here. So I can make a table for these, probably is the easiest way to look at this. T starts off at 0. Now at 0, I better get this point right here, which is right there. Which is 0, negative 1. So I better get 0, negative 1 when I plug in t of 0. So let's try that. When I do it up here, I get, this one gives me 0, negative 1. So that works. This one works, A. Let's try B. B, plug in 0, you get 0, positive 1, so that doesn't work. Here you get negative 0, 0, so 0, 0 doesn't work. And the last one, you get 0, negative 1, so that one works as well. So it's between A and D now. So let's try another point. Let's try the point 1. When I plug in 1, I should get the point 1, negative 2. 1 for x, negative 2 on my line. So let's try which equation works. The first equation, when I try that, plug in t of 1, you get 1 comma negative 2, which is what we want. Let's try the last one to make sure that doesn't work. When I plug in 1 for t, I get 1, 0, and that's not on my line, so therefore the last one doesn't work. So there's the parametric vector equation that represents this line. So A. Okay, the next problem is similar to what we did before with the circle. This circle, if you graph it, using your formula for circles that we know, x minus h plus y minus k, where h and k is the center, and this is r squared. The center is at 4, negative 3, hk, and the radius is 8. So when we write our parametric equations, we'll do x in terms of t here. We know we're going to start off at 4, and then we're going to add on 8 cosine of t like we did before, because we want to go out to this point here knowing that cosine starts off at its highest value 1. So we want to go all the way out to 12 here. And then for y of t, we know that's going to be the y coordinate negative 3, and we're going to add on 8 sine of t. We want this sine to start off like we did in the last problems at its middle value 0. So that when we add this, we get, just negative 3, which is right there for the initial starting point for t. Now, this answer looks like it's D right here. I know it's written a little differently. This is written, these two are switched, but that's the answer. It's also not written in parametric mode. It's written in vector parametric, where you have the x, y coordinates put together like that. Okay, the next problem wants to find coordinates 0, 3, and 8 of this. So we're just making a table, basically. We have t, x, and y, and we're saying if we plug in 0 for t to start, what would the corresponding x value be, and what would the corresponding y value be, and then if we plug in 3, if we plug in 8. Now your calculator will do this for you if you graph both these in parametric mode and look at your table in your calculator. We can also do this by hand as well. When you plug in 0 up here, you get x of negative 1. When you plug in 0 to the y equation, you get negative 5. And then same thing, plug in 3 now for t here. That gives you Now it's probably easiest, I think you get negative 271, but it's easiest probably to use your calculator. If you plug these into your calculator into y equals here, make sure you're in parametric mode, and go to second table set. Make sure you start at, actually I can start at 0 here because that's what I'm looking for. Go by table increments of 1, or 1 will work, and then take a look at your table. You'll see that 3 is negative 271, and then the y value is 724. And then I asked for 8 again. 8 was one they wanted, which was negative 5121 and then 98,299. Yeah, so I'm looking for when t is 0 right here. Also when t is 3 right here. And then also when t is 8 right here. Those are the points I'm looking for. Obviously, enter these in as an ordered pair, like negative 1, negative 5, and you get the idea. Negative 271, comma 724, and so on. All right, let's try another eliminating the parameter one. Let's take the first equation and solve for t. So we get t equals x over 2. And let's plug that t in for this t and this t up there. So we'd have y equals inverse tangent of x over 2 squared plus e to the x over 2. And there's our answer. A little bit tricky to enter in. We'd have to enter this arctan into the Webwork and then be careful with parentheses here, but that should give us our answer. Okay, let's try another one. Let's solve this one for t and plug it in to eliminate the parameter again. So we have y minus 5 equals 5t, divide both sides by 5, and you get t equals this. Let's plug that in right there. So we get x equals y minus 5 over 5 squared. And we have to FOIL this out, unfortunately. So we get x equals y squared minus 10y when we FOIL the top plus 25 all over 25. And that should work fine. You might want to write it y squared over 25 minus 10y over 25 plus 1. And so your a is actually going to be 1 over 25. Your b is going to be negative 10 over 25. You could simplify that a little bit if you wanted, and c will be 1. Okay, and the last one, same thing. We want to put this into y equals by eliminating the parameter. So you can do this both ways, but I guess I'll try solving for t in the first equation x. So I'll make this e to the x equals 7t, divide both sides by 7. So there's my t by itself, and I'll plug that in right here. So I get y equals 1 minus this e to the x over 7, and that should work just fine.